Hello children.
How are you? Before starting the new session, let me ask you a few questions, which we have discussed in a previous class. What is a pull or a push acting on an object called? Yes, it is force. What is the force involved in kicking a ball? Muscular force. What is the upward force acting in the string? Tension force. What is the force that opposes the relative motion between two surfaces? Friction. In the previous session, we have discussed about contact forces. Now, let us discuss about non-contact forces. Non-contact forces. It is the force that acts when bodies are not physically in contact with each other. It is also called as field force or force at a distance. Magnetic force, gravitational force, and electrostatic force are the examples of non-contact forces. Take a bar magnet and place it on the table. Place an iron nail on the same table at certain distance from the bar magnet. Move the bar magnet nearer to the nail. What did you notice? The nail gets attracted by the bar magnet. Even though there is no contact, bar magnet attracts the nail. The force exerted by a magnet on magnetic substances is called magnetic force. So, contact is not required for the magnet forces to come into play. We call this force as non-contact force. What happens when you drop a stone from a certain height? It freely falls to the earth. Why does it fall to the earth? It is due to the attractive force of the earth on the stone. The force of attraction of earth on an object is called gravitational force. In fact, the attractive force between any two masses in the universe is called gravitational force. It is a non-contact force as it is applied without any physical contact. Take a balloon, inflate it and tie the open end. Now cut a paper into small pieces and place them on the floor. Rub the balloon with a silk cloth and bring the balloon near the pieces of paper. What happens now? When the balloon is rubbed with silk cloth, it acquires an electrostatic charge on its surface. When it is brought near the pieces of paper, the paper pieces acquire opposite charge and will rise and cling to the balloon. It is the force of attraction or repulsion exerted between charged particles. It can be either between the same charges, repulsive, this means they repel each other, or between opposite charges, attractive, this means that they both attract each other. Example, when you rub a plastic scale or plastic comb against your hair or a silk cloth, it attracts tiny bits of paper. It is a non-contact force. What is net force? Net force is defined as the sum of all the forces acting on an object. It is also called resultant force. When two or more forces are acting simultaneously on an object, the resultant force can be 0 or greater than 0. Forces are classified as balanced and unbalanced forces based on the net force. Balanced forces. When two forces acting on an object are equal and opposite, then the net force acting on the body is zero. Such forces are said to be balanced forces. Due to balanced force, there will be no change in the state of the body, that is, body is equilibrium. Example, a book placed on the table. Gravitational force, that is, weight acts downward and normal force acts upward. These two forces are equal and opposite. So, the net force is zero and book is at rest. Unbalanced forces. When two forces acting on an object are unequal, then the net force acting on the body is greater than zero. Such forces are said to be unbalanced forces. Due to unbalanced force, there will be a change in the state of a body. Net force is equal to F2 minus F1 equal to 10 Newton minus 5 Newton is equal to 5 Newton towards right. Free body diagram. The schematic diagram that shows all the forces acting on a body in different directions is called free body diagram. It is used to calculate the net force. Now, let's discuss about net force. Example, for a book placed on the table, gravitational force, that is weight, acts downward and normal force acts upward. These two forces are equal and opposite. So, the net force is zero and book is at rest. Calculation of net force. Imagine two forces F1 and F2 are acting on the same object and F2 is greater than F1. Mathematically, the net force can be calculated by the given formula. If they are in the same direction, then net force equals to F1 plus F2. If they are in opposite direction, then net force equals to F2 minus F1. For example, observe this diagram. On this body, four forces are acting. Along the x-axis, horizontal direction, the forces acting are force applied and frictional force. Therefore, the net force acting along x-axis equals to applied force minus frictional force. Along the y-axis, vertical direction, the forces acting are normal and gravitational force. Therefore, the net force acting along y-axis equals to normal force minus gravitational force. In this session, we have discussed non-contact forces and concepts of balanced and unbalanced forces. Write the answer for the following questions in your classwork. Classify the following forces into contact and non-contact forces: frictional force, gravitational force, normal force, tension force, electrostatic force, magnetic force. Calculate the net force for each of the following free body diagram. Thank you. Bye for now,